Hi students, today we'll discuss about a bridge rectifier circuit. This is also very important one in ADC subject. Basically we have three types of rectifiers: half wave rectifier, center tapped rectifier and bridge rectifier. These are the three basic rectifiers. In those three, anyone will come in the examination. Compulsory question in the university examinations. So here this is the transformer. This is a transformer. Here we are giving input as Vm sin omega t, AC input signal. This is Vin. So Vin is equal to Vm sin omega t. In terms of omega t, we are taking in input, that is Vi is equal to Vm sin omega t. Vm is the amplitude. So this is the step down transformer. This can convert AC input signal into step down AC. This is our output of the transformer. This is acting as the input for the rectifier circuit. Same as the previous one. This is the input for the rectifier circuit. In this bridge rectifier we are using four diodes. This is a bridge network. That is why this is called as a bridge rectifier. Here we will go to the operation. This is the input signal we are giving as the input to the bridge rectifier circuit. Then for example I am giving positive signal for positive peak. If my input is positive peak, what is the output? So again I draw this circuit here for the operation purpose. This is the positive signal. Positive we are giving as the input to the this bridge network. Then positive comes here up to here, and positive connecting to the D1 positive, and positive connecting to the D4 negative. This is positive and negative. This is negative and this is positive. We know about diode. So this is anode and cathode. Here cathode and anode. Here we are giving positive peak. This is the positive peak we are giving. That is why D1 is on and D4 is off. Then there is no connection between this bridge network. Open circuit. If it is not connecting, or reverse bias, positive is connecting to the D4 negative. That is why this is reverse bias. That's why this is not connecting. Then D1 is on. Why? Because positive is connecting to the positive of the diode. So D1 is in forward bias. Then similarly this is on. The same input passes through the D1 and comes here. Again this positive is connecting to the D2. Again D2 negative. This connecting to D2 negative, diode negative. That is why this is again reverse bias, open circuit. Then the signal pass through RL. Positive, and comes to this side, again come to here. So up to here we have positive. Already this is a open circuit. There is no current flows through the D4. Then positive connecting to the positive of the D3. This is positive, this is negative. So positive connecting to the D3 positive. That is why D3 will on, and this is up to here we will get the corresponding output. And if the current flowing through this, there is no connection. That is why the current pass through this closed loop path via transformer. Again it repeats the same path, that is looking like this. For positive peak, the current path is looking like this. In this way the current flows in the network, in this bridge network. So that is why there is some voltage across the load resistance, that is a V0, same as the positive peak signal. This is input we are giving with maximum voltage Vm. That is why Vm we are getting as the output. So this is the input signal what we are applying at the secondary of the transformer. So this is the positive peak. For positive peak we are getting same positive as the output. So here D1 is on and D3 is on. D1 D3 on for positive peak. Similarly for negative peak, I am giving during positive peak D1 and D3 will on. Then we will get the output as Vm same as the input signal. that is a Vm sin omega t. So Vm will get as the output. Then during negative half cycle, negative is passes through like this. The negative is connecting to D1 and D4. So here already D1 is forward bias. So D1 connecting to positive connecting to negative. So negative is connecting to this D1 positive. That is why D1 is reverse bias. This will off. There is no connection. Then negative is connecting to the D4 negative. That is why this is forward bias. D4 will on. Then current passes through like this up to here. Here we have negative is connecting to positive of the D3. So this will off. Why? Because this is reverse bias. Then current passes through this path like this through RL, and up to here we have a negative is connecting to this diode negative, then this will on. Similarly this is also connected, but there is no closed path. That is why D1 is there is no closed path. That is why this is passes through the D2. So negative is connecting to D2. This is forward bias. This will on. This is passes through like this, and it will try to pass towards the D3, but D3 is already open circuit. That is why the current passes through this and passes through the transformer. So this is a complete loop. So like this the current will pass. This is the closed loop. Then the output V0 across RL is V0 is equal to Vm. So here across load resistance the maximum passed voltage is Vm plus Vm. That is why we are getting plus Vm as the output. Then here D2 and D4 is on. Similarly I am applying positive peak again. If I apply positive peak again, the same operation will be repeat. So for all positive peaks D1 D3 on, for all negative peaks D2 D4 will on. So from 0 to pi Vm, and pi to 2 pi also same Vm, same input we are passing through the rectifier circuit. This is about operation of the bridge rectifier, and the parameters are maximum, all parameters are same for the bridge rectifier and the full wave rectifier, except peak inverse voltage and transform utilization factor are different. Remaining all parameters are same. Peak inverse voltage is Vm here, and transform utilization factor is 0.821. So peak inverse voltage is Vm. Peak inverse voltage is nothing but whenever we are applying the input signal, which diode is reverse bias, or the diode is reverse biased at which applied voltage, that is peak inverse voltage. If you see here, for positive peak 2 diodes only on, 2 diodes off, and for the negative peak again 2 diodes on and 2 diodes off. That is why Vm plus Vm for 2 diodes by 2, so 2 Vm by 2, then the peak inverse voltage will be Vm. And for full wave rectifier the transform utilization factor is 0.6, here 0.8. The transform utilization factor is high. Efficiency is 81% and the refill factor is a 0.48. Remaining all parameters are same except peak inverse voltage and transformer utilization factor. You have to write remaining parameters also for this bridge rectifier. Don't forget to write all those parameters: VDC, VRMS, refill factor, peak factor, form factor, all those same as the full wave rectifier. Only peak inverse voltage and transformer utilization factors are different. The peak inverse voltage is a Vm and the transformer utilization factor is 0.8. We have to calculate that, same as PDC by PAC rated. Okay, this is about bridge rectifier. Thank you.